Alexander Block is our next presenter, and he is a PhD candidate in Computer Science Department in the College of Science. His fun fact is that while he is originally from South Los Angeles, California, he has spent the last 7 years at Purdue and has learned to appreciate many of the small-town quirks of the greater Lafayette area. Maybe those others of you from California can get that too. He enjoys cooking, loves snowboarding, and can't resist a good hike in the mountain, forest, or even the desert, none of which we have around here. He hopes to have one day to visit every national park in the United States, but for now he enjoys relaxing at home with his cat, Groat. The title of his 3MT presentation is Encoding Schemes with Message Symbol Recovery that Resist Edit Errors.
Picture yourself at NASA. You are tasked with designing a communication system to let NASA talk with the rover on Mars. The rover is millions of miles away, and you need to send messages that are subjected to numerous hazards, like asteroids or solar flares. The messages you send can be the difference between a new scientific discovery or the rover tumbling off a cliff. How do you ensure the rover doesn't turn left when you say turn right? How do you ensure the rover receives your message when it can be filled with errors and portions are deleted or replaced with garbage? These are some questions studied by coding theory. Coding theory studies two people just trying to talk to each other, like NASA and the rover. However, messages sent by NASA can become full of errors while in transmission. To handle this problem, coding theory gives us encoding schemes. An encoding scheme is just a way for NASA to rewrite one message as another message with a lot of redundancy to handle errors. For example, NASA can rewrite the message turn right as turn right repeated 4 times. We call these rewritten messages encoded messages. Once a message has been rewritten using an encoding scheme, NASA can send it to the rover. When the rover receives the message, it can use the redundancy in it to recover the original message. The key feature of an encoding scheme is that as long as the encoded message doesn't have too many errors, the rover can always recover the original message. My research is in the design and analysis of encoding schemes with something called message symbol recovery and can resist edit errors. Let's break down what this means. Message symbol recovery means that when NASA gives an encoded message to the rover can look up individual symbols of the original message without reading the whole thing. For example, NASA can take an enormous spreadsheet of information and rewrite it with the encoding scheme, and the rover can look up individual entries of that spreadsheet without reading the whole thing with message symbol recovery. Edit errors are errors which can insert symbols into or delete symbols from messages sent by NASA. For example, an asteroid can come crashing into the message turn right and transform it into turn left or delete it entirely. My research uses tools from cryptography to design 3 new encoding schemes with message symbol recovery and that can resist edit errors. Before my work, there is only one encoding scheme with both these properties. My schemes are nearly the best they can be in terms of 1, how short the encoded messages are, 2, how many errors the encoded messages can handle, and 3, how long it takes the rover to perform message symbol recovery. These encoding schemes are just one part of my broader thesis, which examines connections between coding theory and cryptography. My research has the potential to serve as a basis for more reliable, secure, and resilient communication across the world, with the added benefit of letting NASA talk with the rover on Mars. Thank you very much.